I know where there's some, right here in the hall, clerk.
No, Molly, not in there. I have enough.
Okay, here's the first capacitor can out of the radio. I cleaned up the terminals. It's an original Zenith labeled part. Zenith. It has 40 at 450 and another 40 at 450, and it says on there the can is common negative. So that's handy to know. And what there is on here is this, the can itself is folded over and presses down on a ring. This ring that goes right around here, and that's ground, that's common. Then the two 40 microfarad capacitors, leads pass through these two holes. So what I have to do is begin to pry this lip up, and I'll work my way around it as gently as I can so as to not tear this aluminum up. Pull the innards, pull the ring off, the grounding ring, and pull the innards out. Keep this phenolic layer because it has, our keys, it has, I don't know if you can see that. It has a triangle here marking one capacitor and a semicircle here marking others. So we have to keep those. Well, I don't have to, but it's handy. And it makes it look authentic. So I'll begin by prying this up, and when I get that pried up, I will show you what it looks like. Okay, there's the grounding ring I was talking about. This piece of foil right here attaches to the side of the can and touches this, so just to make sure that this all has good connection in spite of the crimp around here. So what you do next, there's a little slot right there, and depending on how lucky you are, it'll either lift up out of there or it will pull loose and I'm not going to be that lucky. So it's not impossible, it's pretty unlikely, but it's not impossible. This is filled with some substance. So what I'm going to do is go off camera and monkey with this. See if I can just gently pry it up out of there. Perhaps drive a thin tool around the edge to loosen it. Like a, do I have that here? And artists, it's a very thin blade that artists smear oil paints on with. I guess it's upstairs. Anyway, I might try to find that and slip that right down around the edge here, just to make sure that this is loose. Anyway, I'll try that and I'll be back. Alright, with the help of a heat gun, softened this rubber gasket up enough for the cap to come out. And it's typical, it's a rolled, looks kind of like paper or cloth, impregnated with the electrolytic and foil. Oh, I forgot to check. I never did even. I just presumed it was bad. We'll take a look here at the cheap ESR meter and see what it says. Wow, I've never seen it take that long to test anything before. Interesting. It's a capacitor with 37 picofarad. It's supposed to be a 40 microfarad cap there. Let's try the other side. Again, taking a long time. 38 picofarad. Wowzer. I don't know whether that stuff is toxic or not, but what I'll do next, I'll clean the can out. There's a piece of paper down in there, and this just needs washing out and scrubbing. Then I'll strip this back far enough so that I can cut the leads. These are tapped into the foil down in here. And there are two, like I said, there are two caps, supposed to be 240 microfarad caps in here. No longer 40 microfarad. But what we want to do then is clean this out, put our new caps in there. Yeah, anyway, a couple of these will get stacked in there somehow. Not sure how yet. A couple of those will get stacked in there. The two negative leads will get brought out and attached to the steel ring. The positive leads will be fed out through this base here and into these two connectors. Sorry, these two connectors here. So that's the story. As I get it all cleaned up and put the caps in, I'll show you how it all fit together. Alright, it's held together by this tape I just cut. And here you can see the magic of the capacitor. Foil and paper. The paper is theoretically saturated with the electrolytic. This looks like it bounced around in the can. This is all rounded off. I wouldn't expect this to be all rounded off like that. There's where our little tab connects from the foil up to the can. I wonder what that's for. It's metallic. It's almost like lead. Might be another sheet of aluminum. Might be the second cap, actually. So we've got a foil here, paper, another foil. So this might be the second cap. Okay, here's the connector to the paper. Two layers of paper at this point. Yeah, so here's that second layer of foil that we found, and that's connected straight through to this lead. So I'll cut that off right there. Throw one away. And there's our other lead. Right. And there. To the other foil. So that's the lop off. And that's our capacitor. Goes on and on and on down to the core. I wonder if by 1950s, late 40s, they weren't making these by machine. The original ones were certainly made by hand. Yeah, there's the, it's the end of the reel. So you want to know what a 40 microfarad capacitor looks like? There it is. Into the trash with this. And there's what we're left with. So this looks like a piece of phenolic right here. It's the end cap. And a piece of rubber, perhaps. Probably dense or tar. And then a very much thinner phenolic for the inside. So I can solder to these. That's where the two positive leads of the 40 microfarad capacitors will go, and then a negative lead will be brought out probably right there and connected to the can and this piece of steel here that goes right there. That's the story. I'll shut the camera off and get to work. Alright, can's cleaned out pretty well. Here are the capacitors. I have two 450 volt 47 microfarad capacitors. The originals were 40 microfarad at 450 volts. What I've done is soldered the common leads together, the common negative, and then extended one up the side, The other two just come straight out. That drops in there, probably with a bit of hot glue in there just to hold it all stable. It struck me that hot glue is the modern equivalent of tar. And the days this was made, you would pour some hot tar in there, and in fact there was some hot tar in the bottom. But today we use hot glue. So what happened is I made it, you know about assuming things. I did a leap of faith that these guys, since they're steel and solderable, would extend down into here. And it turns out that's not the case. These are actually aluminum, can't solder to them. And they come up here and the steel bit is clamped onto the aluminum that comes up through here. So what I've done instead is I've drilled a couple of small holes right there and there. And the capacitors will fit in like this. Oops. To turn that fit in like that. And that. And the ground wire will fit in that little notch. It's right there. And this will all get pressed back together and the aluminum folded over. Well, that will go on. This wire from the common negative will get soldered to one of these pins. It'll all get dropped back down into the can, and then I'll round off the aluminum again. Here's what I found when I tried to put this all together and into the can, is that this piece is too thick. It stands up too proud because this cap is slightly too high. It can be compressed a little bit, but not quite enough. So this piece is 2 pieces of phenolic with tar or rubber in between. Can't tell which, but it doesn't matter. I'm going to remove that one. Looks like tar. These solder points are held in place by these tabs, and that one's about shot, as is that one. Yeah, I don't know if you can, yeah, you can see that one split right there. But it will have to do. Now, let's see. Oh, much better. Now I've got room for the grounding ring and to rebend the aluminum around the edges here. So that's good. I'll show you what this looks like when it's all buttoned up. And here is the result. From the top and most of the sides, it looks like a normal capacitor. On the bottom, you can see where I had to reform it. There might be a nicer way to do this. I just don't know what it is. And I always get in a hurry and I get aggressive at the beginning, and so that causes divots like that. But once it's down in the chassis like that, I think it'll look fine. Let's make sure our cap survived the transition with the cheapo ESR meter here. Yeah, 47 microfarads, 1% V loss, CSR of 0.67 ohms, which ain't much. Let's try the other one. Okay, 49 microfarads, CSR of 0.74 ohms, V loss of 0.9%. So our transplant was a success. We'll be able to use this cap in the radio. All right, moving on to the Discriminator Transformer. I'm going to have the transformer out here. I haven't opened it up yet. We'll do that in a minute. I'll show you where it's at. Let me show you where it's at. It's this guy right here. And this side ohms out properly. This side ohms out as an open. So there's something awry in here. I think I'll talk about this a bit later in this video, but I was making a fuss about how little information, this is a writer's schematic, and how little useful information writer has, except that I got a copy of the schematic for this chassis from Sam's PhotoFact, and although the PhotoFact has a lot of useful information, it does not include the pin numbers of the IF cans. So, you know, I guess to get all the information as possible, you have to have a schematic from each one. At any rate, what we're going to do is open this up, take a look, and see if we can find out why this coil measures open. And also take a look and see if these look like they're silver mica, and decide what to go do from there. So let's start with this. And these are just held together with bent end tabs. One there, one there, one there, one up there. So I will get a pair of pliers and unbend those tabs. As you can see, I just nipped the wires that were going in here. I find it so much easier to clean up contacts when they're not in the chassis. And this one in particular is down in the corner of the chassis and hard to get at. Okay, one more. Okay, if I refer back to the schematic, the coil we're interested in is between pins 2 and 3. So the number 1 pin is marked with this arrow right here, and it's clockwise since we're looking at the bottom. So that's pin 1, there's 2 and 3. So let's see what's going on here. Orient myself again. Here's pin 1, here's pin 2, and here's pin 3. And as far as I can tell, the wires are in place. Oh, wait. That's pretty loose. The other thing I notice is they're not elegantly wound coils. This one has come unshellacked or unlacquered, whatever it feels like it's not anchored. So that may be the culprit. The first thing I'll do is I will resolder these points right here and see if that brings back connectivity. Sometimes it's just a bad joint there. As to the next question, I'm referring back to the schematic, which says there are capacitors in here. 2, 3, 4 capacitors. I'm having a hard time spotting 4 capacitors. Oh wait, there's some mica right there. See the really shiny stuff? I suspect that's a mica sheet. So the capacitors are tucked up under here. Boy, that's ugly. Well. Well, first things first. Let me reflow these 2 connections right here, and we'll find out if that will help. Okay, the pins in question are right here. So what I'll do is do a little dab of flux. It's water-based flux. On there. Well, a little heat and some solder. Let's see what happens. Holy smokes, don't tell me. Miracle of miracles. Okay, the schematic says it's supposed to be 0.5 ohms, and it looks to me like it's now 0.5 ohms, give or take. Very good, that worked. All right. However, it does not solve the larger problem, or the larger potential problem. That has to do with the capacitors. I can't see why else. There would be this. Let me get as close as I can here. Nope, too close, won't focus. In any case, I can't see why else there would be this mica plate under here, or plastic plate. Actually, it would be good if it was a plastic plate. That would mean it wouldn't be silver mica disease, if it has it. There's no evidence right now to be clear that it has silver mica disease. I think what I'll do is clean these contacts up, put it back in the can, and put the whole thing back together, and wait until I'll confirm once I've got it reassembled that I still have continuity between here and here. But I'll wait until the chassis comes up and we get to hear whether it has crackly issues or not. I'll also take my super magnifying business and look at this wire to make sure it isn't broken somewhere along the way. It looks like it's just so sloppily done. I'm impressed at how sloppily done it is. It might be homemade. Might be the technician fixed it in the past. Don't know. Anyway, that's what I'm going to do next. And I'll put it back. But right now, I want to talk just a minute and finish up this video talking about schematics. Schematics. And how varied they are and their availability on the internet. One of the greatest resources for anybody who does radios, of course, is the radiomuseum.org. Up here you can see. And this is one of those schematics. If you contribute almost anything to them, they will give you download privileges until you die. So it's a great resource. However, sometimes what they depend on is what people upload, scans of things. And here's an example. This is the 10H20Z schematic that's available from the Radio Museum. And I will just zoom in here a bit. And as you can see, it falls apart really quickly. It becomes, the scan was such low resolution that you can't zoom in very far before things disappear. So it's better than nothing for sure, but in this case, barely better than nothing. This one isn't very terribly useful. So, Radio Museum, great resource. Some schematics, and I shouldn't say this reflects on all of the schematics you can download from there, because it does not. Some of the schematics are very high res. Others are like this, where, geez, lots of scan artifacts. The detail drops out so quickly, you really have a hard time reading it. So that's one resource. Another is the writer's schematics. Sorry. This is from the manual of 1951, most often needed radio diagrams. And it's better. It's also from the Radio Museum. Same radio, exactly. But it's a better scan. So as you can see, there's detail here that was really missing on the other one. You can actually read the numbers on this discriminator transformer here. That one is a little dodgy, but I presume it's an 8. So it's better. This is probably, and I'm not sure I can say one way or the other for sure, but this is probably a writer schematic. And as you look at schematics online, writers are available everywhere. Everybody has a writer schematic for almost every radio in the world that you can download and use. And the writer schematics are really quite fabulous. They really work well. They give, where would I find? all of the components are listed, their values are listed, which is great. Voltages right here, 220 volts DC, that's fabulous. They even give the pin numbers of the IF cans, which is a great thing. I mean, I'm not faulting that at all. But when you get down here, for example, oop, how can I do this? Oh, over here, no. Well, down in here, there are two transformers. This is the audio output transformer. This is a power transformer. And the audio output transformer says 300 ohms on a center tapped primary, and 3 ohms on a secondary. And that's all the information you get. So, writers, lots of good information, very useful, but limited. So, is there another option? Yeah, there is. There's the old SAMS. The SAMS PhotoFact is fabulous. Here's the schematic for the upper right-hand corner of exactly the same chassis. Very clean. I love the SAMS layout. The SAMS layout of schematics is very tidy, very useful, very clean, and it works really well. If we look in the same corner up here, yeah, you can see it's just open space, lots of room. Every component has an individual number. The writer's schematic for this particular radio, for example, says R15 for used. And so you look at the schematics and you realize that R15 is all, it's a label for all resistors with the same resistance. So there could be 4 of them throughout this circuit. They're all labeled R15. They all have the same resistance, and good luck in picking one out. So, well, I see in the bottom of the chassis a 15K resistor. Which one is it? Well, it's R15. They're all fit that resistance. So writers, here's the way I think about it. I think that Zenith in this case came up with a schematic. SAMS took it, made the highest quality schematic they could. Their own draftsmen, their own standards. The only issue I have with the SAMS schematics is this font. I just hate this font for their component numbers, because it's so I don't know, 1932. You know, it's so hard to read once it's shrunk down a little bit. But great schematics, fabulous schematics. Everything is identified. Every component has its own number. It's great. It's so cleanly drawn, and I love it. And right down here is a big win. Writer's schematic for this radio has no voltage readings, and it has no resistance readings. And the voltage readings on the writers, to be fair, are scattered, you know, on various lines throughout the schematic. But I just love this table. This tube, this pin should have this amount of voltage on it. No questions. And again, if you want to do resistance tests, which is a great idea before you power something on to make sure you're not too far out of the ballpark, the SAMS has a table, which works quite well. So the next thing that I want to gripe about is alignment. This is the alignment procedure from the Radio Museum, one of them. And it's the worst ever. Here's FM. Recall that this chassis does both AM and FM mono, no FM stereo, FM mono. And it says FM alignment, because of the wide band pass, it's desirable to use an FM signal generator and a cathode ray oscilloscope when aligning. The instruction book for the Zenith Model 800 signal generator, form Z8001, covers complete FM alignment procedure. Now, I challenge you, or anybody else, to find that document. The entire FM alignment instructions for this radio are right here in this completely useless paragraph. And then you go on to the next paragraph, FM discriminator alignment, which is the transformer we worked on in this video. When the secondary of the discriminator is aligned, operation 5, who knows what that is, use sufficient signal, blah, 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 to set the, get a good positive and negative indication before setting the slug for 0 reading. I'm not stupid, I don't think. I'm old and tired, but I'm not stupid yet, as far as I know. But geez, this is just completely useless. So let's look at what Sam's says about aligning the radio, and it's right here. Documentation has radio alignment instructions, AM, FM AIF alignment using a signal generator and VTVM, or FM IF alignment using a signal generator and an oscilloscope. In other words, they have it all. It's right there, the whole thing. And it even shows you down here what the waveforms for the